imagine incredible things with all its stars and galaxies. But some areas are extremely mysterious. These are places with super strong gravity. These are black holes. Imagine a place where gravity is so strong that nothing can escape. Not even light can get away. These scary parts of space are called black holes. They form when giant stars fall in on themselves because of their own gravity. Black holes make us rethink how we understand physics. They push the limits of what we know about the universe. Come with me on a trip to explore these mysterious objects. Let's find out the secrets hidden in their darkness. Our exploration will take us to the edge of what we know. We will go deep into the center of these scary monsters. Get ready for a journey into the unknown. Black holes aren't just empty space. They are places that are super tightly packed. Imagine squeezing the entire sun into something the size of a city. That's how tightly packed a black hole can be. Because they're so dense, they have a really strong pull. It's so strong that nothing can escape. Not even the fastest thing in the universe, light, can get away. Black holes come in different sizes. Some are only a few times heavier than our sun. Others, called supermassive black holes, are millions or even billions of times heavier than the sun. These supermassive black holes live in the centers of galaxies. They change how the entire universe grows and changes. Their gravity decides what happens to stars and galaxies. At the very center of a black hole is a spot called the Singularity. This is where what we know about physics stops working. Here, gravity is unbelievably strong. The Singularity is a point that is packed together more than anything else. All the stuff in a black hole is squeezed into this one tiny spot. Imagine squeezing the entire Earth into a grain of sand. Quantum mechanics, the rules for how tiny things work, also matters here. It tells us that the Singularity might not be a point, but more like a blurry area. This area follows the rules of quantum gravity, which we are still trying to figure out. The Singularity is a place of extremes. It's a place where the laws of physics we know don't work anymore. Studying it could help us discover new things about gravity and the universe itself. Black holes don't just affect things right next to them. Their strong gravity bends the fabric of space-time itself. Imagine a bowling ball on a trampoline making it dip down. That's kind of how black holes warp space-time. This bending has big effects. It changes the way light travels when it's near a black hole. This bending of light is called gravitational lensing. It can make faraway objects behind the black hole look weird and stretched out. The closer you get to a black hole, the more warped space-time becomes. Time itself slows down as you get closer to a black hole. This is because the strong gravity changes both space and time. Studying how black holes warp space-time helps us understand Einstein's theory of general relativity. It helps us understand how gravity works in extreme conditions. The point of no return, event horizon. Around a black hole is an invisible line called the event horizon. This is the point of no return. Once you cross it, you can't come back. Not even light can escape the black hole's pull from inside the event horizon. The event horizon isn't a real wall. You wouldn't feel anything special if you crossed it. But once you're inside, you're trapped forever. Gravity would pull you toward the Singularity, and you couldn't escape. The size of the event horizon depends on how heavy the black hole is. The heavier the black hole, the bigger its event horizon. Some supermassive black holes have event horizons billions of miles across. The event horizon is a really interesting idea. It's like the border between the universe we can see and the hidden parts of a black hole. It reminds us how powerful these objects in space really are. Echoes from the abyss. Hawking radiation. Even though nothing can escape a black hole after crossing the event horizon, black holes aren't completely black. They give off a faint glow called Hawking radiation. This glow is because of quantum mechanics happening near the event horizon. Pairs of particles constantly appear and disappear in space. Near a black hole, one particle might fall in while the other gets away. The particle that escapes takes a little bit of energy from the black hole. Over a very long time, this makes the black hole smaller and smaller until it disappears. Hawking radiation is very faint and hard to see. But it changes how we understand black holes and how the universe changes over time. Unraveling the mysteries. New horizons in black hole research. Scientists are always working on new ways to study black holes. One amazing thing was the first ever picture of a black hole's shadow, taken by the Event Horizon Telescope in 2019. This picture proved that black holes are real. It showed that many of our ideas about them were right. Researchers are also studying gravitational waves, which are like ripples in space-time caused by heavy objects like black holes moving around. By looking